Finally, we're going to discuss the last two possibilities regarding compositions of trigonometric functions and inverse trigonometric functions. We already discussed the case in which you're composing a trig function with its own inverse, and you could have two different orders. The inverse function could be outside or it could be inside. Now, we want to discuss the case in which you have combinations of different types of inverse functions. So these two functions may be different. It doesn't have to be a function and its own inverse. So for example, you could have sine inverse composed with cosine. Or you could have cosine outside and the inverse sine inside. Okay, so for this example, number 8, we're going to first treat the case where the inverse function is outside. This is the easy case. The more interesting case and more convoluted is the case where the inverse function is inside. So we're going to devote more examples to that case. For the case in which the inverse function is outside, is really just straightforward. Just basically evaluate the inside and then do the outside. That's it. All right, if the angle though is a special angle, you're really supposed to do this without a calculator because you don't want decimals, like you want the actual exact expression. If it is not a special angle, then just use the calculator and give the answer as a decimal. Let's start with this one. Let's do one of each. One where you have a special angle and one where you don't have a special angle. So this one is a special angle because it is 13 pi over 6, and we know that pi over 6 is a special angle. A multiple of a special angle is a special angle. So that one is a special angle. I'm going to do without a calculator. Okay, so just do the inside, as I said, and then do the outside. So let's start by doing the inside. Okay, so we have to then, question is, what is the inside? We have to figure out this first. What is the cosine of 13 pi over 6? Well, let's do, first know that this angle is actually quite big. It is bigger than 2 pi. You could draw a picture, but look at this. 13 over 6 is actually what? Is actually 2 and 1/6. Right? So what it actually means is that 13 pi over 6 is 2 pi and 1 over 6 pi, or pi over 6. That's what that means. Okay, so this is equal to that. So it is 2 pi plus pi over 6. And now if you remember, cosine is periodic with period 2 pi, meaning that if you have an angle and you add 2 pi to it, it doesn't really change anything. So the cosine of pi over 6 should really be the same as the cosine of 2 pi plus pi over 6. If you add 2 pi, again, it doesn't really change the value. So these two things are the same. Now, what is this though? This one you're supposed to know this one by memory. This one is square root of 3 over 2. So if this one is square root of 3 over 2, that means that this one is square root of 3 over 2. So we have then the cosine of 13 pi over 6 is square root of 3 over 2. All right, and then going back here, that tells me that this is equal to, well, we just figure out the inside. The inside is square root of 3 over 2. All right, and now we're just almost done. Now all you have to do is think of an angle between negative pi over 2 and pi over 2, because that is what sine inverse is going to always spit out, an angle between negative pi over 2 and pi over 2. Think of an angle between negative pi over 2 and pi over 2 whose sine is square root of 3 over 2. And again, this is a special angle, so you really should know this one from memory. Thinking about it, it really should be pi over 6. I mean over 3. If that's what you thought, then you got that right. Pi over 3 is an angle between negative pi over 2 and pi over 2 whose sine is square root of 3 over 2. And that's the end of this story. So that's how you do it. Do the inside first, figure that out. If it's a special angle, do it using the unit circle. So in this case, I broke that up into a mixed number, and I could subtract 2 pi. Basically, this is just finding a coterminal angle because this is too big. So if you remember about coterminal angles, you add pi, subtract, you add 2 pi or subtract 2 pi to come up with coterminal angles. Coterminal angles have the same picture, so they have the same values of sine and cosine. Then I know this one, so that means I can replace that with that and then finish it off. All right, if it is not a special angle, you may use a calculator. This is not a special angle, so let's use a calculator for this one. And we're going to give the answer. Remember, unless specified, we use radians. That's the convention. We're going to use radians. Okay, so we're going to do sine. Make sure it's in radians. This is not in radians. This is in degrees. We should change it. Also, I know it's in radians because there's no degree symbol. If there was a degree symbol, then I would have to use degrees, but there's no degree symbol, so this is for sure radians. All right, so sine of 0.25, and that's what you get. You get cosine inverse. Copy the whole thing. Do not round. You only round when you're done with a problem, not before. So copy the whole thing. 2474.03959. Okay, I copied the whole thing. Then you're going to find cosine inverse of that. So cosine inverse of 0.2474.03959. You're going to get 1.3208, rounding to 2 decimals. And this is radians because inverse trig functions spit out angles. Okay, this is an angle in radians. You could have just entered the whole thing at once. That's another possibility. I mean, it's easier. You don't have to copy that much. You could just have said cosine inverse of sine of 0.25. And there you go. Same thing, even easier. Okay, so that's how you do the composition of trig functions when the inverse function is outside. Now let's do compositions when the inverse function is inside. This is the interesting case, the one that requires more steps. I have written all the steps right here. Might be a little bit wordy, but let's follow them, and once you do it a few times, you will see how this is done. Okay. The very first step, if you have a composition where the inverse function is inside, the very first step is you're going to give a name to the inside. You're going to let theta equals cosine inverse. We use theta because, again, cosine inverse spits out an angle. So theta is the appropriate name, a Greek letter. Okay, so give a name to the inside. That is the first step, done. That's the first step, that's all. Step 2, second step, is rewrite this without using inverse function. Okay, for reference, again, I wrote all the steps here in words. I'm not going to do that here. But step 2 is rewrite everything without inverse functions. So that means I want to use a regular cosine, not cosine inverse. So regular cosine is, using regular cosines, this becomes cosine of theta equals 4/5. Because the input becomes the output becomes the input. That's it, step 2. Rewrite without using inverse functions. Step 3, you're going to reinterpret this using SOHCAHTOA. You're going to use SOHCAHTOA and you're going to draw a right triangle. So how do you do that? So this is how you do it. We're going to reinterpret this using SOHCAHTOA. SOHCAHTOA tells me that this is SOHCA adjacent over hypotenuse. So now I'm going to think of this as a ratio using SOHCAHTOA adjacent over hypotenuse. And then I'm going to draw a triangle using this fact. This is theta, let's call that theta. The adjacent is 4, the hypotenuse is 5. The adjacent is 4, the hypotenuse is 5. So this is 4, and this is 5. Once you draw that picture, step 4 is you're going to complete that triangle. You're going to find the missing side. So let's complete that triangle. I'm going to draw it here again. So question mark, what is this? Let's give it a name. I like using ABC for the sides of a right triangle, so I'm going to use B. Using the Pythagorean theorem, this is 5 squared equals 4 squared plus B squared. Simplifying, this is 25 equals 16 plus B squared. Subtracting 16, you're going to get 9 equals B squared. And taking square root on both sides, you get that B equals plus or minus 3. Remember that from college algebra, whenever you take square root on both sides, you have to go plus or minus. That's the rule. Now, of course, a negative answer doesn't make any sense, so we have to say that B equals 3. So going back here, that means this is 3. And now we're basically done. We're essentially done. Step 5 is read off the final answer from this. So what is the final answer? How in the world would you write down the final answer now? Well, look at what the question was. The question was find what is sine of cosine inverse of 4/5. That's what the question was. The original question. We call the inside theta. So that means the question is what is sine of theta? From this picture, we can tell what is sine of theta. So what is sine of theta? SOHCAHTOA is opposite over hypotenuse. So it is 3/5. And that is the final answer. 3/5. All right, that's it. We're done. All right, let's do a few more. Let's try this one. Oops. All right. Okay, let's try this one. It says sine of tangent inverse of 7/4. Okay, step 1 is, I have more space in this page, so I might write the steps. First step is give a name to the inside. Let theta be the tangent inverse. So give that inside a name. Done. Step 2, rewrite without using inverse functions. So I want to rewrite that equation without using inverse functions. So that means I want to use regular tangent. If I use regular tangent, this becomes what? This becomes tangent of theta equals 7/4. The output becomes the input becomes the output. Step 3. You're going to reinterpret using so, ka, toa, and a right triangle. We're going to reinterpret this equation using SOHCAHTOA and a right triangle. Okay, SOHCAHTOA tells me, SOHCAHTOA, this is tangent, so this is opposite over adjacent. So if I draw a picture, a right triangle, and I call that theta, then the opposite is 7, the adjacent is 4. The opposite is 7, the adjacent is 4. Step 4, complete the triangle, meaning find the missing side using Pythagoras theorem. Okay, so let's find the missing side. So this is 4, this is 7. Again, I like using ABC, so I'm going to call it C. You can call it whatever you want. Pythagoras theorem tells me the hypotenuse squared, C squared, equals the first leg squared and the second leg squared. Simplifying, this is C squared equals 16 plus 49. And then simplifying, what is this? This is 65. And then taking the square root on both sides, you get C equals plus or minus the square root of 65. Remember that you have to put plus or minus whenever you take the square root on both sides of an equation. The negative one doesn't make any sense. So of course, the answer is going to be just square root of 65. Okay, so that is C. So you can go back here and say this is actually square root of 65. And now we have completed the triangle. The last step, step 5, is write down final answer. Write down final answer from the triangle. You can just look at the triangle and give the final answer. Again, how is that done? Well, what was the original question? The original question was, what is sine of tangent inverse of 7/4? What is sine of tangent inverse of 7/4? We call it inside theta, so the question is, what is sine of theta? Oh, I forgot to label this. This is theta. I didn't need it for applying Pythagorean theorem, but now I do need it. Just that's where I have the theta. Okay, just copy that. All right. So what is sine of theta from this picture? Sine of theta, so is opposite over hypotenuse. That is the final answer. Opposite over hypotenuse. 7 over square root of 65. Okay, that's how you do that. Now, if you have a problem where there's no numbers, but there's variables, it is done actually exactly the same way. So let's do a couple of examples where it's not just pure numbers, it's actually there's variables in there. Okay, the procedure is done exactly the same way. Let's start step 1. Give a name to the inside. So let theta be equals sine inverse of x over 3. Okay, step 2. Rewrite it without inverse functions. Rewrite it without inverse functions. So I want to rewrite it using regular sign. What would that be? That would be sine of theta equals x over 3. Now we're going to reinterpret that using SOHCAHTOA in a right triangle. Sine of theta equals x over 3, but I know that that is opposite over hypotenuse. So I can draw a right triangle using this information. The opposite is x, the opposite is x, the hypotenuse is 3. Step 4, complete this triangle. So I'm going to give this side a name. I like ABC, so I'm going to call this one A. We have to find A. What is A? Well, apply the Pythagorean theorem. Pythagorean theorem tells me hypotenuse squared equals A squared plus x squared. Simplify, this is 9x squared plus x squared. And then I want A, so that means this needs to move to the other side, so I have A all by itself. So this is 9 minus x squared equals A squared. And lastly, take square root on both sides. Square root on both sides, we're going to get plus or minus square root of 9 minus x squared equals A. But of course, again, this is a geometry problem. Negative answer doesn't really make any sense, so A is just positive square root of 9 minus x squared. So that is what A is. In other words, A equals, going back here, square root of 9 minus x squared. And that's it, we're almost done. Step 5, write down the final answer. Okay, what was the question to begin with? The question was, find cosine of sine inverse of x over 3. Find cosine of sine inverse of x over 3. But we call the inside theta. So the question is, what is cosine of theta? And we have this picture here. From this picture, what is cosine of theta? That would be adjacent. So adjacent over hypotenuse, which is 3. And that is it. This cannot be simplified, so that is the final answer. Okay, if you think you are understanding all this, give this last example a shot. Try it, like really try it. Pause the video and try it. All right, let's do it. Step 1, let theta be the inside. Remember, arcsine is just the same as sine inverse, so the inverse function is inside. Okay, so theta equals arc sine of 2 over x. Good. Step 2, rewrite this without sine inverse, without arc sine. You want this using regular sine. So what would this become? This would become sine of theta, output becomes input, input becomes output. Sine of theta equals 2x. If you don't like that notation, you can change it to sine inverse. I'm leaving it like that, but you can change it. All right, third step is reinterpret this equation using SOHCAHTOA and a right triangle. So this is sine of theta equals 2 over x. SOHCAHTOA tells me that this is opposite, so opposite over hypotenuse. So that allows us to draw a right triangle real quick here. If this is theta, the opposite of that is 2. Opposite is 2, hypotenuse is x. Opposite is 2, hypotenuse is x. So the triangle looks like that. Step 4, we're going to complete this triangle using Pythagoras theorem. I'm just going to draw it again. Okay, and we need to figure out what that side is. Let's give it a name. Let's call it A again. Pythagoras theorem tells me the hypotenuse squared equals A squared, one leg squared, the other leg squared. So A squared plus 2 squared. Simplifying, this is x squared equals A squared plus 4. Move the 4, so I have A all by itself. So I would have x squared minus 4 equals A squared. Almost done. Take squared on both sides. Don't forget that the rule from college algebra is whenever you take squared on both sides, you have to put plus or minus. However, again, in this context, the negative answer, the negative possibility does not make any sense. So it's just positive square root of x squared minus 4. And that is A. Going back here, we can complete this picture and say this is x squared minus 4. Last step is read off the answer from there. So what is the question? The question is, what was the question? Cosine, find cosine right here. The question is, what was cosine of arc sine of 2x? So what is the cosine of arc sine of 2 over x? But we called the inside theta. So question is, what is cosine of theta? In this picture, what is cosine of theta? What is cosine of theta? From this picture, so Ga, it would be adjacent over hypotenuse. Adjacent is x squared minus 4. Hypotenuse is x. So the answer is square root of x squared minus 4, all that over x.